And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks within less than 5 minutes. So without wasting time, let's get started. So today's problem of the day is insert in sorted way in a sorted doubly linked list, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given the head of a doubly linked list, and the structure of that doubly linked list is something like this. Data will be there and there will be two node pointers, previous and next, because in doubly linked list there is both previous, there are two pointers, one is pointing to previous and another one is pointing to next. Okay, all right, and then there is one integer x. So we have to make a node of x and we have to insert it such that the linked list, the doubly linked list, remains sorted. Okay, and we will be given a sorted doubly linked list. Let's see one example and it will become more clear to you then. So the example here is, let's take this one, 3 5 8 10 12, and we have to insert 9. We have to insert 9. Okay, all right, so what we will do, we will first of all iterate over the whole linked list. We will iterate over the whole doubly linked list. Look, if my current is, let's say, at 3, so I will check, like, current is 3, so basically current means, basically what we will be doing, we'll be inserting before that. Okay, all right, if current is 3, so it means before that, before 3 we cannot insert. If current is 5, it means before 5 we cannot insert 9. Okay, before 8 also we cannot insert 9. Now before 10 I can insert 9, before 10 I can insert 9. Okay, so what I will do, I will simply make a node of 8, of 9 value. Okay, let's suppose this is the node and I will do some pointing. 8's next will be pointing to 9, 9's previous will be pointing to 8, 9's next will be pointing to 10, 10's previous will be pointing to 9, and that's it, and we will simply return the head. Okay, so this is the logic. As I told, the logic is what? Logic is very simple. We will be iterating over the whole linked list and we will check if the we can insert before it. Suppose if this is 5, so we can insert before it. If yes, so we will insert, but linked list should be sorted. So to insert, like to insert 9, our current should be greater than 9, then only we can insert. Okay, all right, so that is the case. Greater than or equal to both we can use. Okay, all right, so I think the problem statement will be clear. Now there are few edge cases. First one is, let's say I got my let's say I have to insert 1. I have to insert 1, so we have to insert it at the very beginning. Okay, so what I will do at that point, I will simply do what? I will be making a one node and I will check, like, 3 is my current head, and I will check if I can insert before 3. How? If x is less than or equal to current, that is 3, so we can insert it. Okay, so what I will do, I will simply one and point some pointers in like this way, and I will simply return the new node 1, because we have to, our new head is this one. Okay, all right, first case is covered. I think second case is already simple. Now third case is, let's say x is equal to 15. For this you will see x is equal to 15 here. So what I will do, I will simply keep on iterating over the whole linked list till we can insert the value. I think that point is clear, but now 15 is there, so 15 will be at last. Okay, I will check if my current is null. If the current is null, so what I will do, I will simply 11 next will point to 15, and 15 next, 15 previous will point to 11, and these one will be pointing to null. This will be still pointing to null. Okay, because at initialization also you can see both are pointing to nulls. So we don't need to do anything. Okay, all right, so that is it, guys. That is it. Very, very simple. There will be three cases I have already mentioned. One where I have to insert at the very beginning, second where we have to insert in the middle, and third where we have to insert in the last, at last. Okay, all right, so I will request everyone to please pause the video and try to write the code by you. All right, I hope many of you will be able to solve it, but if not, let me code it for you. But before that, if you have loved the explanation, please don't forget to subscribe the channel and share your feedbacks. Okay, all right, so first of all, what I will do, I will simply make a new node. Let's say I name it to insert. Okay, and it is a new node, and I will pass x to x here. It means a new node will be created with name to insert. Its data will be x, and its previous and next will be pointing to null. Okay, all right, now we will cover the first case. First case was what? If we have to insert in the very beginning. So for that, what I will do, x is less than or equal to head dot data. Okay, x is less than equal to head dot data. It means we can insert it at very beginning. So what I will do, x dot next is equal to head. Okay, head dot previous, sorry, no, it will not be x, the node is this, to insert. Okay, to insert dot next is equal to head, and head dot previous is equal to insert, because it's doubly linked list, and simply we will return to insert here. Okay, all right, so this is the first case covered. Okay, all right, after that, look, the another case was what? While, let me take a temporary variable current, node current is equal to at head dot next, and previous is equal to head, so that I can keep account of both my current node and previous node. So if I know my current node, let's suppose I'm currently at 10, and I know my previous node 8, so it will become very, very easy. 8's next will be 9, and 9's previous will be 8, so that 8 we know. Okay, so that's why I'm storing it into the previous variable. Okay, all right, and now what I will do, I will simply write something like while current not equal to null and x is greater than x is greater than what? Current dot data. Okay, so if this is the case, we will keep on iterating. We will keep on iterating. Why? Because we cannot insert. Like suppose 5 is there, current is 5. So 9 is greater than 5. So we cannot insert 9 before 5. Okay, so we will try to insert before current. Okay, all right. I hope that this point is clear to everyone what I'm trying to say. So what I will do, I will simply update my previous. So previous is equal to current and current is equal to current dot next. Okay, all right. I hope this is clear. After that, look, now either I have reached to the end where it is null or I am in between. Okay, all right. So if I am in between, previous will always be there. Okay, so what I will do, I will simply do previous dot next is equal to insert. Okay, and to insert dot previous is equal to previous. So this previous is this node previous. Okay, and this previous is the this one. Okay, all right. Now I will have to check one more thing. So if my current is present or not. If current is not null, so we have to add few more things. So if current not equal to null, it means what? It means what? Current dot previous is equal to insert and to insert dot next is equal to current. Okay, and after that, very simple. Let's simply return our head. Okay, because we are not changing the head at any point, our head is still the same. We are operating on current and previous. So if you are not sure about this point, I will explain again. This point means key if I'm at 10 12, so now suppose this is at null. Okay, so our current will be at null. If my current is at null, so we cannot have to do something like current dot previous is equal to insert. We don't need to do. Okay, but if my current is 10, then we have to do something like current dot previous is equal to 9 and 9 dot next is equal to current. So that is what I'm doing here to check if it is we are at the last or not. Okay, all right. I hope the problem statement and explanation, the code will be clear. Let's try to run this. Meanwhile, please hit the subscribe button, guys. The subscribers are not increasing and I'm very much disheartened by it. All right, it's getting accepted in my first attempt. It was a bit easy side problem, I will say. Okay, all right. I will see you again tomorrow. Till then, keep on coding and keep on subscribing and sharing your feedbacks into the comment, and I'm going to see you again tomorrow.